Now, let's take a look at a couple of functions that we can use on matrices. You're already familiar with them, but there is something tricky when it comes to matrices. First, let's take a look at the sum function. The first time you use the sum function, it will probably work in an unexpected way for you. You would probably expect to get the sum of all elements in the matrix and get only one single number as a result. And let's see if that is the case. Sum of some matrix. Let's run it. And surprisingly, that is not the case. Now, it's important to realize that MATLAB prefers to work in columns, contrary to what we are used to. We would expect it to work in rows, but it prefers columns. I have briefly touched on this in previous lectures, but here I'm going to explain it in a bit more detail. The sum function didn't give us one final result. Instead, it gave us the sum of each individual column and returned a vector as an answer, a vector of sums. This is our matrix, so sum matrix, and 1 plus 1 plus 6 is 8, 2 plus 3 plus 7, 12, and so on. Usually, when it comes to learning about sum and the rest of the functions that I will now show you, many lecturers or instructors will tell you, yeah, if you want the full sum of the matrix, you simply need to use the sum function twice. Fair enough, it will work. Let's see it in action. So, the sum of the sum matrix gives us this vector, and then we need to take the sum of that vector. So, sum of sum. Let's run it, and we get the answer. Fair enough, it's working, but it's not practical. But there is a better and easier way to do it. There is a way to do it by using the sum function only once. And I will show you that way, and then I will show you why it's better to use that way. So the way is to simply say sum of the matrix, so sum matrix, open brackets, and here simply give it the colon operator, nothing else, and close the sum brackets. That's all. If we run it, both will produce the same result. First, there is no speed difference between these two approaches. If you have some very large matrix, both approaches will be equally fast. So, why do I tell you to use the second approach? The second approach looks cleaner, it's easier to write it, you write less, and because matrices can have more than 2 dimensions. Here we need to use sum twice because our current matrix has only 2 dimensions. Matrices can have 3, 4, 5 or more dimensions when you start working with large pieces of data. And if you want to take the sum of that large matrix that has more than 2 dimensions, if it has 4 dimensions for example, you have to use the sum function 4 times, like this. Yes, this will work for a 4-dimensional matrix, but look how much you need to write. You have to write sum 4 times, use a ton of brackets, and it just looks ugly. Sum of sum of sum of sum. While this approach will work for any dimensional matrix. So get used to using this way. Get used to whenever you want to select the whole matrix, simply use the colon operator. Now, what does the colon operator actually do? If we use only that, the colon operator transforms the whole matrix into one single column. Now, if you take a look at the matrix itself, you can see that here we start 1, 1, 6, 1, 1, 6, then we continue 2, 3, 7. So what MATLAB does is that it takes each of the columns of the matrix and it puts them below the previous column. That way it creates one giant column. If you work with a matrix that has more than 2 dimensions, it will do the same thing. Eventually, regardless of how many dimensions your matrix has, it will be dumped down to one single giant column. And then you are able to use the sum function only once. This is why you are able to use the sum function only once when you use the colon operator because that will force the matrix to become one giant column, so you will have only one dimension at that point, and you need to apply the sum function only once. It's important to also note that the sum function also has a second argument, dimension. What this argument does is that it determines how the sum function works, whether it calculates the sums by columns or by rows. So if I remove the column operator now and turn it, we know that these are the sums by columns. If we want to get the sums of the matrix by rows, we have to say comma, and we have to give it the second dimension. So here you simply give it on by which dimension you want to get sums. So when we say 2, we say that we want to get the sums by rows. That's why we get a column vector with only 3 values. And if we use 1, we get a row vector. It is also interesting to note that this is not the default behavior of the sum command when it comes to working with vectors. With everything that I said up until this point, and if you haven't seen the sum function before, you would expect that since MATLAB works in columns, if we pass a row vector to it, we would get the same vector back instead of its sum, since a row vector has many columns. Each individual element is a column, and you would expect that since by default the sum function takes sums by columns, that you will simply get back that same vector. That is not the case. The sum function will actually first detect the size of the collection that you give it, and if one of the dimensions is of size 1, it will default to the other dimension. So if we use it on a vector and we give it that same, if we give it the second dimension as an argument, we get the sum. We get the sum because we are telling it to sum it by rows. But if we give it 1, we are telling it to sum by columns, we get back the same vector. Now if I remove this and I run it like this, we still get the sum. So look at this. Sum of a matrix and sum of a vector. The sum of matrix with no dimension specified gives you the sum by columns, and sum on vectors gives you the sum by a row. So it defaults to the dimension that is not 1. If you have a vector, the sum will work as expected. Now similarly, there are three other functions that I want to show you that work in the exact same way as the sum function. So I will just quickly go over these functions because all of the things that I just said in this lecture apply for these functions. And these are the mean, and the max functions. So the mean function of some matrix will give you the average by columns. If you give it 2, it will give you the average by rows. If you say mean of the whole matrix, it will give you the mean value between all of the values in the matrix. Mean simply means average. We have seen how to calculate average with size and with sum, but we actually have a function for that in MATLAB. The next is the min of some matrix. Again, works the same way. Let's also take a look at the max. So some matrix. So both of these will give you the minimum and the maximum value by columns. If you give them second dimension, they will now work by rows, but not really. There is one tricky thing here. You need to supply one empty argument, one empty second argument like this. And if we now run it, we get the minimum and the maximum values by rows. And finally, if you want to find the minimum or the maximum value in the whole matrix, simply select the whole matrix with the column operator. So the minimum value is 1, the maximum value is 8.